calculus friends. I really wish I could teach you this in person, but since I can't, let's do an example of composite areas between curves. The biggest thing with composite areas is that instead of just doing top function minus bottom function integrating, they will switch places. So for example, we have the function y equals negative x squared plus 4x plus 3, and the function y equals negative x cubed plus 7x squared minus 10x plus 5. See, I wrote these down right. If I didn't, it won't work. 4 plus 4x plus 3. Good. So now the first thing you do is you graph the functions on your calculator. I'm not going to show you that. Then you adjust your windows so that you can see what the functions are doing, where they're intersecting, and also what the bounded areas look like. And you find intersection points. In this case, when you graph it, you'll end up with something like this. Your cubic function will look something vaguely like that. You know, my drawings are great. And then the quadratic will look something like that. Yeah, close enough. Okay, so then our bounded areas are in here and in here. I'm actually going to trace over one of the functions in a different color. So let's make the cubic function purple. Okay, let's go back to the blue. So if you look, the cubic function is on the bottom in that first area, and then it's on the top in that second area, and that's why we will need two integrals. Using your calculator once again, you can find your intersection points. This occurs when x equals 0.157. This intersection point occurs when x is 2.307. The last one occurs when x is 5.357. You know, you guys know how I like the defined functions. So I would define f of x equals negative x squared plus 4x plus 3, our quadratic, and define g of x equals negative x cubed plus 7x squared minus 10x plus 5. And then from there we set up our two integrals. So our first bounded area is from 0.157 to 2.307. And if you look in there, the quadratic, which is blue in this case, is above the cubic. So then our quadratic is f of x. So we'll have f of x minus g of x dx. Put brackets around here if you want to be, proper. Plus, we have that other area from 2.307 to 5.357. And in this case, the purple function, or the cubic, is on top. So we have g of x minus f of x dx. And assuming you defined your functions, from here it's just calculator work, and your area should be 28.276. Don't forget those 3 decimal places. That's all for the moment. Thanks, guys. See you soon, hopefully.